Now let's talk about the cotangent function. And what we're going to do here, we got a couple of examples of some transformations of a cotangent function. And we're going to discuss what those transformations are and how it may affect the period and other things. Reflections, whether we're vertically stretching or compressing, so on and so forth. And then we're going to go to the calculator and actually graph them. But as we consider that, let's think about the cotangent itself. So the cotangent is the reciprocal of the tangent function. And if I go back to SOHCAHTOA, well, I know that the tangent function is the opposite side of, let's say, theta over the adjacent. And so the reciprocal, the cotangent, then is the adjacent over the opposite. And then if I think about the tangent function on the unit circle, or on the coordinate plane, let's go coordinate plane first, and unit circle, basically the same thing. But tangent, then we said, was y over x. So that means that cotangent must be x over y. And then as we considered the unit circle, we defined the tangent as the sine of x over the cosine of x, sine over cosine, which means then the cotangent must be the cosine of x over the sine of x. Or another way that we could look at it is that the cotangent is equal to, and I guess I should put theta here, 1 over the tangent of theta. That's the reciprocal, right? Isn't that the reciprocal? Yeah, that would give us the reciprocal. So if the tangent of theta then is, let's say we said was the sine of x, or theta, over the cosine of theta, well then that's 1 times the reciprocal, so we got the cosine of theta over the sine of theta. Just how we defined it. And this 1 over the tangent of theta is how we're going to graph that using our graphing calculator. Now let's look at the transformations that are taking place. First thing I see here is I got a negative cotangent. So what's that going to give us? That is going to give us a reflection. It should be over the y-axis. A reflection over the y-axis. And then we've got the cotangent of 3x. So that's b. That's going to affect my period, and it's also going to affect my asymptotes. Now, if my period then is determined by pi over, for cotangent, or for our tangent cotangent functions, over the absolute value of b, well, that's going to be pi over, in this case, 3, because the absolute value of positive 3 is in fact 3. So my period is pi over 3. Then I'm going to have asymptotes less than half of that and more than half of that. So let's see, what about I'm going to take this pi over 3 and divide it by 2, which is pi over 3. I'll get ahead of myself. Times 1/2. And so I'm going to have asymptotes at plus or minus pi over 6. Okay. Yeah. And we're looking at that maybe from the origin and then filtering on out. Now let's look at this second cotangent function. I got 3 times the cotangent of x over 2. Well, there's 3 out front. I'm going to see this is going to be vertically stretched by 3, by a factor of 3. Now, what about my period? Again, I start at, now this is the same as 1/2 x, right? X over 2 is the same as 1/2 x is also the same as 0.5 x. All of that's 1/2. So my b is 1/2, and our period, we start at pi. Now we're divided by 1/2, aren't we? Okay, 1/2. Well, that's going to equate to pi times 2, or 2 pi. So now I've got a period of 2 pi. Interesting. Now, what about my asymptotes? Well, my asymptotes are going to be half that amount, plus or minus half that amount. So I got 2 pi over 1/2, over 2, which is the same as 2 pi times 1/2. We got 2 pi over 2. Well, that's where I started, isn't it? I could have just simplified that. What am I doing? Let's just simplify that. And so we're going to have asymptotes from the origin, let's say, at plus or minus pi. Now let's go graph these things and see how they look. What do you think? All right, well, let's see. We're over here at the calculator. Let me clear out what I've done here before. We're going to clear that. We're going to clear that. And let's just start off by graphing just the cotangent function without any transformation. So I could just say, okay, well, let's see. Let's go. We got 1 divided by the tangent of x. And let's see what this cotangent function looks like. Okay, so I still have my window setting set with a y minimum of pi and a y maximum of 2 pi, and my scale is pi over 2. And you see how this is flipped. My tangent function started from down at the bottom left and kind of swirled up to the top of the right between the asymptotes, and the cotangent function is actually just flipped over. It's reflected right there. And well, Shazam, there we go. And I've got an asymptote at pi. My period is pi. And so I've got an asymptote here at pi and at 0. Okay. Well, that's pretty cool. All right, let's graph then our transformation. And our first transformation there was negative cotangent. So I'm going to go negative. And then I'm going to put this in parentheses. 1 over, and now I'm going to use a parentheses again, the tangent of 3x, and let's double close these parentheses. They need to triple close it. Let's see what happens here. All right, well, there we go. Okay, so what did we say we thought was going to happen? We thought this thing was going to be reflected over the y-axis. The red is our transformation. So it has flipped it over across the y-axis. It's actually made it look like a tangent function, hasn't it? That negative has made it look like a tangent function from the bottom left up to the top. And let's see, what about our period? We said our period was going to be from pi over with a total period of pi over 3. Let's see how that looks. Here's pi. We're coming right here. Yeah, that's probably pi over 3. 1/3 pi. This is half pi, starting from the extreme left to this point right there. So I could see that being pi over 3. Pi over 3 is less than 1/2, isn't it? 1/3 is less than 1/2. And then what about our asymptotes? Well, I'm going to kind of start here from the origin. And so from this point to this point, if you can see it, x-intercept to x-intercept, would be, yeah, I could see that being 1/3 pi over 3. And so then we got an asymptote here at pi over 6. I got one at negative pi over 6. I got an asymptote coming down the other way at 0. That asymptote at 0, and then another one over here at positive pi over 6, and so on and so forth, going right and left and right on the graph. Now, let's look at what the next one was, which was y equals 3 times the cotangent of x over 2. So I'm going to leave our basic parent cotangent function in place. I'm going to just change this y2. And now we've got 3 times the cotangent. So I'm going to put a parentheses 1 divided by the tangent of x over 2. Oh, went too many. 2. Let's close that parentheses. We're going to double close it. And let's see what happens to our graph. There comes my first one. Let me go back in here. I think I don't like the way that looked. Try it again. Let's see, let me change my window setting. I think that's going to change the way that's going to look. I got it set at negative pi and positive pi, and now my period, because of that pi over 2x, is going to be 2 pi. So I'm going to change my x minimum to 2 pi. No, I need to do that to negative 2 pi. Negative 2 pi. We're just working as we go. And we'll change my x maximum to positive 2 pi. So we should see at least one period here. Let's see how that may change our graph. All right. And so it has, I can see that it in the red, it's vertically stretched, my graph. Okay, that's not, I don't see quite the curve that I did before. My period is 2 pi. And that means I should see asymptotes at pi. I've still got a scale of pi over 2. So, an asymptote right there. Asymptote right there. I'll go back in and look at my window setting again. 3 times the cotangent of pi over 2. Okay, so there we go. We've seen a vertical stretch. Our period has stretched out. We've stretched our horizontal axis, our period, by 2, going from pi on the period to 2 pi, which then, of course, has affected our asymptotes. And there we go. Yeah, we're at pi over 2. So I got an asymptote here at pi. This is 3 pi over 2 right here on the left, where I see up here in the top left, going down to the bottom right, which is negative pi over 2. This is negative 3 pi over 2 on the left side of this, negative 3 pi and negative pi over 2. That should give us a period of pi. That's what I'm looking for. Looks good. There we go.